Hello everyone. Today we shall be dealing with the entity relationship modeling topic. An entity may be defined as a thing with an independent existence and which can be uniquely identified by a set of attributes. An entity is a thing that exists either physically or logically. An entity may be a physical object such as a house or a car or a student. Entities can be thought of as nouns. For example, a computer, an employee, a song, a mathematical theorem, etc. A relationship captures how entities are related to one another. Relationships can be thought of as verbs linking two or more nouns. For example, an owns relationship between a company and a computer. A supervisor's relationship between an employee and a department. A performs relationship between an artist and a song. A proves relationship between a mathematician and a conjecture, etc. A relationship is also said to be an association that exists between two or more entities. Entities and relationships can both have attributes. For example, an employee entity might have a social security number, while a proved relationship may have a date attribute. Every entity must have a minimal set of uniquely identifying attributes, which is called the entity's primary key. An entity is a collection of related types of entities. An entity set may contain entities with attributes sharing similar values. For example, a student's set may contain all the students of a college. A faculty set may contain all the faculties of a college from all departments. Entity sets need not be disjoint. Now let us see what attributes are. Entities are represented by means of their special properties called attributes. All attributes have values. For example, a student entity may have name, class, age, hall ticket number as attributes. There exists a domain or range of values that can be assigned to attributes. For example, a student's name cannot be a numeric value. It has to be alphanumeric. A student's age cannot be negative. It has to be a positive value, etc. There are several types of attributes. The first one of which is the simple attribute. Simple attributes are atomic values which cannot be divided further. For example, a student's mobile number is an atomic value of 10 digits. Composite attribute. Composite attribute made of more than one simple attribute. For example, a student's complete name may have first name and last name. The next attribute is the derived attribute. Derived attributes are the attributes that do not exist in the physical database, but they have values that are derived from other attributes present in the database. For example, average salary in a department should not be saved directly in a database. Instead, it can be derived. For another example, age can be derived attribute from the date of birth. The other attribute is a single value attribute. The other type of attribute is a single value attribute. Single value attributes cannot Single value attributes contain single value. For example, UID number. The next type of attribute is the multi-value attribute. A multi-value attribute may contain more than one values. For example, a person can have more than one phone number or email address, etc. Entity set and keys. Key is an attribute or collection of attributes that uniquely identifies an entity among entity set. For example, the roll number of a student can make him identifiable among the students. Super key. A set of attributes, one or more, that collectively identifies an entity in an entity set. A candidate key. A minimal super key is called a candidate key. An entity set may have more than one candidate key. Primary key. A primary key is one of the candidate keys chosen by the database designer to uniquely identify the entity set. Relationship. The association among the entities is called a relationship. For example, an employee works at a department, a student enrolls in a course. Here, works at and enrolls are relationships. Relationships set. A set of relationships of similar type is called relationship set. Like entities, a relationship too can have attributes. These attributes are called descriptive attributes. Degree of relationship. The number of participating entities in a relationship defines the degree of relationship. Binary, degree 2, ternary, degree 3, n-ary, degree. Mapping cardinalities. Cardinality defines the number of entities in one entity set which can be associated with number of entities of other set via relationship set. One to one. One entity from entity set A can be associated with at most one entity of entity set B and vice versa. One to many. One entity from entity set A can be associated with more than one entities of entity set B. However, an entity from entity set B can be associated with at most one entity. Many to one. More than one entities from the entity set A can be associated with at most one entity of entity set B. However, an entity from entity set B can be associated with more than one entity from entity set A. Many to many. One entity from A can be associated with more than one entity from B and vice versa. ER diagrams in database management system. So coming to the next topic, let us see how can we draw an entity relationship diagram. Entity relationship diagrams are used to model real-world objects like person, a car, a company, and the relation between these real-world objects. An ER diagram has the following features. ER diagrams are used to represent ER model in a database, which makes them easy to be converted into relationships or tables. ER diagrams provide the purpose of real-world modeling of objects, which makes them intently useful. ER diagrams require no technical knowledge and no hardware support. These diagrams are very easy to understand and easy to create even by a naive user. It gives a standard solution of visualizing data logically. To draw ER diagrams, we use several notations. Let us see what are these notations. A rectangle represents an entity. A diamond symbol represents a relationship. An oval represents an attribute. A double rectangle represents a weak entity. A double-lined diamond shape represents a weak entity relationship. A double ellipse represents a multi-valued attribute. An ellipse in which the attribute is underlined represents a key attribute. An ellipse, again subdivided into two or more ellipses, represent a composite attribute. So these are the various symbols that are used in order to draw an ER diagram, that is the entity relationship diagram. Now let us see what are the components of an ER diagram. An ER diagram constitutes of the following components. First one, the entity. Any real-world object can be represented as an entity about which data can be stored in a database. All the real-world objects like a book, an organization, a product, a car, a person are the examples of an entity. Any living or non-living objects can be represented by an entity. An entity is symbolic representation by a rectangle enclosing its name. Entities can be characterized into two types. The first one, strong entity. A strong entity has a primary key attribute which uniquely identifies each entity. The symbol of a strong entity is same as an entity, that is a rectangle, single line. A rectangle with a single line. The next entity is a weak entity. A weak entity does not have a primary key attribute and depends on other entity via a foreign key attribute. A weak entity is represented as a double-lined rectangle. For example, when projects are allotted for the students, a student represents a strong entity, whereas the projects allotted represents a weak entity. Coming to the next component, the attribute. Each entity has a set of properties. These properties of each entity are termed as attributes. For example, a car entity would be described by attributes such as price, registration number, model number, color, etc. Attributes are indicated by ovals in an ER diagram. A primary key is depicted by underline in the ER diagram. An attribute can be characterized into the following types. Simple attribute. As in the above example, where car is said to be an entity and price, registration number, model number, and color are the attributes. We can classify these attributes into various attributes like simple attribute. An attribute is classified as a simple attribute if it cannot be partitioned into smaller components. For example, the color in the car entity, or the age, or a sex of a person. A simple attribute is represented by an oval. Composite attribute. A composite attribute can be subdivided into smaller components which further form attributes. For example, the registration number of the car in the above said example can be further divided into a number of attributes or a number of simple attributes. Like for example, the registration number the code of the state, etc. For example, name attribute of an entity person can also be thought as composite attribute. This can be broken down into first name and last name, which can further form attributes. Grouping of these related attributes forms a composite attribute. Name is the composite attribute in this example. Single valued attribute. If an attribute of a particular entity represents a single value for each instance, then it is called a single valued attribute. For example, Ramesh, Kamal, and Suraj are the instances of the entity student, and each of them is issued a separate roll number. A single oval is used to represent this attribute. Multi-valued attribute. An attribute can hold more than one value. It is then termed as multi-valued attribute. For example, a person can have more than one phone number. Hence, phone number can be thought as a multi-valued attribute. The symbol of a multi-valued attribute is shown in double ellipse. Derived attribute. A derived attribute calculates its value from another attribute. For example, age is the best example of a derived attribute. It calculates its value from the current date and the date of birth attributes. A derived attribute is represented as a dashed oval. The next component of the ER diagram is the relationship. A relationship is defined as an association between two or more entities, or it can also be called as bond or attachment between two or more entities. Normally, a verb in a sentence signifies a relationship. For example, an employee is assigned a project, a teacher teaches a student, author writes a book. A diamond is used symbolically to represent a relationship in the ER diagram. Teacher teaches a student. This is an example of a relationship in an entity relationship or the ER diagram. Various terms related to the relationships. Degree of relationship. It signifies the number of entities involved in a relationship. Degrees of a relationship can be classified into the following types. Unary relationship. If only single entity is involved in a relationship, then it is a unary relationship. For example, an employee manager supervises another employee. The next type of relationship is the binary relationship, where two entities are associated to form a relationship. Then it is known as binary relationship. For example, a person works in a company. Most of the times we use only binary relationship in a ER diagram. The teacher student example signifies a binary relationship. Other types of relationships are ternary and quaternary. A name signifies a ternary relationship is associated with three entities and quaternary relationship is associated with four entities. Connectivity of a relationship. Connectivity of a relationship describes how many instances of one entity type are linked to how many instances of another entity type. Various categories of connectivity of a relationship are one-to-one. Student is allotted a project signifies one-to-one relationship because only one instance of an entity is related with exactly one instance of another entity type. One to many. A department recruits faculty is a one-to-many relationship because a department can recruit more than one faculty, such as faculty member is related to only one department. While drawing these relationships, the entities are represented in the form of rectangles and the associations are represented in the form of diamond. An arrow pointing towards the entity, if it is having if it is a single arrow, it is called a single association, whereas if the arrow is a crow-footed one, it says it is one-to-many relationship. Many to one relationship. Many houses are owned by a person is a many to many relationship because a person can own many houses. A particular house is owned by a single person. So always the many-sided entity is represented with a crow-footed on the back side of the arrow. Many to many. Author writes books is a many to many relationship because an author can write many books and a book can be written by many authors. So that's all about ER diagrams in DBMS. So we have studied various components of an ER diagram, various symbols and notations used in the ER diagram.